Welcome to the lesson on sex-linked traits and pedigrees. In this lesson, we'll be discussing what sex-linked traits are, how they were discovered, and we'll show a couple examples of sex-linked traits. We'll then discuss what pedigrees are, 3 possible patterns of inheritance, and then we'll do a few examples of pedigrees and information you can get from them. All right, let's start with sex-linked traits. Sex-linked traits were discovered by Thomas Hunt Morgan in fruit flies with the white eye trait. What he noticed was that male white fruit flies, when they were crossed with females that had red eyes, that the first generation all had red eyes. Well, this clearly indicates that white eyes must be the recessive trait. However, in the second generation, when those red-eyed fruit flies crossed, all the females had red eyes, but half of the males had red eyes, while the other half of the males had white eyes. Now, this doesn't make sense from Mendelian genetics. We would have to see at least some of the females also have to have white eyes. What this indicated to Thomas Hunt Morgan is that the trait for the eye color must be linked somehow to the sex of the fruit fly itself. And hence, sex-linked traits were discovered and born. What we've learned is that sex-linked genes are carried on the X chromosome. All right, let's do a little review here. You may remember that females have 2 X chromosomes and males have an X and a Y chromosome. So, in this particular case, the gene for eye color and dominant being red, so we would say the X chromosome carrying the sex-linked gene for red eye color, since red is dominant, would be a superscript R. So we give the X chromosome a superscript R for red eye color, and we give it a lowercase r for white eye color. So, males would have an X and a Y, but the sex-linked trait for eye color in this case is only tied to the X chromosome. So the male genotype, if the male has red eyes, would be X big R Y. If the male fruit fly has white eyes, it would be X little r Y. However, we see 3 options with females because they have 2 X chromosomes. A female with red eyes could be homozygous red, X big R, or heterozygous red, X big R, X little r. Since the red is the dominant trait, it would mask the little r in the heterozygous female. The only way for the female to show the trait is to have the recessive trait on both of her X chromosomes. X little r would be females that show white eyes. All right, so let's take a look at what he did here and how he discovered this. All right, so he started out by crossing a white-eyed male. So if it's a white-eyed male, it would be X little r Y with a homozygous red-eyed female. And so that would be X big R, X big R. let's go ahead and finish out the square for this. What would we get? X big R, X little r, X big R, X little r, X big R, Y, X big R, Y. Okay, so a couple of conventions here. We just always write X's before Y's because that's how it's done, and we always put dominant traits in front of recessive traits, just like we did when we did our other genetics problems. Okay? Now, so these are the offspring from the parents. This would be the F1 generation. Now the F1 generation reproduces, and what do we get? Well, we had 50% males that were X big R Y, and 50% females that were X big R X little r. Let's go ahead and do those crosses. So this would be X big R, X big R, X big R, X little r, X big R, Y, and X big R, X little r, Y. You can see there it is. In this second generation of offspring, we have a 25% chance of getting a male fruit fly with white eyes. Notice we didn't end up with any females ever that had white eyes in this cross. Okay? So let's talk about that next. The only way for a female to get the sex-linked trait is for the father to have it. In order for the father to have it, he would have to be X little ry, and the mother to be a carrier. To be a carrier means you'd have to be heterozygous. Mother would be two X's, and heterozygous would be big R on one and little r on the other. Or have the trait herself. In order to do that, she would be homozygous recessive, having a little r on both her X's. You can see here, this is why it's so rare for a female to inherit a sex-linked trait. Examples of the human sex-linked traits in humans are hemophilia and color blindness. Let's take a look now as our amoeba sisters teach us about hemophilia as a human sex-linked trait.